From geocentric, we descended down to heliocentric,
Absolutely.
and God knows what is in future for us.
So reason is precisely that whereas mathematics that has been used there is irrefutable, the observations that have been carried out have been subjective. There is no objectivity when I look at things, because you see in science, in physics or in biological sciences,
there's all relativity.
Yeah, there is an element of relativity there, an element of subjectivity, because it also entails an element of observation. We perform certain experiments in the lab. There is an intervention of the human.
Here it's no human, it's all impersonal.
It's impersonal, exactly. You see, here you deal exclusively with the world of thoughts and ideas.
Right.
I'll give you a simple example, which an undergraduate who has done physics knows full well. Newton's formula for the velocity of sound. The formula that he had proposed was seen to be incorrect to the extent of 16% of the actual observations that were made. So when Newton looked into it again, he wanted to. He was fully aware of the fact that his formula was inadequate, but then he was not able to find out where the
rub lies.
So he was not able to do it, and later it was a French mathematician, Laplace, who was able to find out the flaw in his argument. So the point I want to make is that Laplace concluded that whereas the piece of mathematics that Newton had applied was correct, there was nothing wrong in his mathematics, there were some deficiencies in his arguments involving the basic observations that he had made. He had assumed that sound travels in a particular manner, which was contrary to the actual way in which it was traveling. So technically speaking, whereas Newton thought that the change was happening isothermally, Laplace said the change takes place adiabatically. So this physical thing, mathematics, with the same piece of mathematics, he got the correct results. Mathematics was what it was.
So there are no counter theories, there are no refutations at all. Whatever is accepted, it's accepted by all. There is no one tomorrow to refute your theory if you float it today as a mathematician.
But then it has to pass through the crucial test of proof. If the proof is logically correct and logically consistent, there is no reason why.
How important is this, the mechanism of proof? What is the role of proof? As we study role of chance in literature, in Shakespearean plays, what is the role of proof in mathematics?
I would say proof is the raison d'etre of mathematics.
Ultimate.
It is the ultimate thing. You see, you don't accept something unless it is substantiated by a logically consistent proof. You see, seeing is not believing in mathematics. I can give you any number of examples where your physical eye directs you to make the following conclusions, but which are not logically correct. For example, if in the plane of the wall I fix a point and another point down there which is not vertically under it, but it is slightly removed from it, you are able to understand?
Yes, of course.
And if I want to let loose, if I want to let go of a particle from this point up there to B, what does your physical intuition tell you? In order for it to reach there in the smallest amount of time, what is the path that it should take?
Yes, sir.
What should be the path?
Path is straight downwards.
It has to be a straight line.
Yes.
Okay, that's what our physics, it reaches that point down there in the least possible time.
Oh, of course, it's very surprising how physical facts sometimes mismatch and give a kind of illusion.
Absolutely.
To us. Sir, we normally take mathematics synonymous with arithmetic. And sometimes we take axiom is same as its postulate. Is there a difference between the two, that what's axiom and what's postulate? Or first, that if mathematics is about the relationship between numbers and arithmetic is about the counting of numbers, are they the same or there's some difference?
You see, arithmetic, I call, put it in, Hindustani, dukandari mathematics, shopkeeper's mathematics. The way you add things, how nicely and how adroitly, how adeptly you add and multiply things, that constitutes the realm of arithmetic. Arithmetic is
simple division, multiplication, addition, and subtraction.
That's it. Well, there are ingenious ways of doing it in a reasonable amount of time. You see, if I give you a 10-digit number and ask you to multiply it by a 12-digit number, it will take quite an awful lot of time for you if you do it the classical, the conventional way. But there are ways, like these, Vedic mathematics, where these Vedic mathematics protagonists. So they have some techniques, some methods, I would say some clever tricks on occasions, which enable you to multiply these big numbers in a small amount of time. But then it's mostly confined to this process of addition, multiplication, division, and subtraction. That's what arithmetic is.
Mathematics is a big subject, which arithmetic is just a part of.
I don't think you can call it a part of mathematics. See, as I said, when you look upon mathematics as the science of patterns, arithmetic automatically falls by the wayside.
Then, sir, is axiomatic truth the same as a postulate?
Well, as I said, axioms are